Okay, so yeah, now let's start with this. So this is the agenda. Like we'll touch on just quickly, have a read through about what is network, its bookish definition, and look at network types, topologies. One of the key concept is OSI model. Uh, that obviously we can't go every layer of the OSI model in depth, but we'll just have a glance of the landscape of OSI model, and then we'll look at what are some of networking protocols uh, which are widely used and which we would need to be aware of for any of the Kubernetes ingress working. And we'll also look into some of the useful CLIs or tools. If time permits, we can go through a demo of those tools. Now, you maybe already have some knowledge of this coming from your academic background, or you might have studied on your own some of these network concepts, but consider this as a refresher, not a full-fledged analysis of each concept of networks. Cool. So what is network? Obviously, by network, by definition, it's connecting two or more computers or two or more computing devices. So even in our day-to-day life, we are communicating over network through our phones. Phones, again, mobile phones connect via same internet as computers connect. Uh, Before mobile phones, obviously, not sure if some of you have not seen, we used to have landline phones. They were connected through wires to telephone center or whatsoever, and they were also using the some of networking protocols. So this is all network. So any, in network communication, obviously there needs to be participation from two or more devices. If a single computer uh, or single mobile phone is not connected to network, it's not participating in any communication. It's just sitting in isolation. Now, what are some of the network types? If you excuse me with my this not so pretty diagram, but yeah, these are the network types that are widely in use. LAN, MAN, WAN. They are abbreviated. LAN is for local area network. MAN is for metropolitan area network. WAN is for wide area network. Now, what is LAN? Do you know? Let's keep this session interactive as much as possible. Can anyone quickly give a definition of LAN?
Local area network.
Yeah, that's the uh, definition of, as in the expandation of LAN, but what LAN comprises of.
LAN is basically used to connect computers like in a building or in local area through wires basically.
Yeah, even if it is not via wire, if it is part of network which is very local to you or your office premise, that is local area network. For example, in your home, you probably most of us are using internet. That's how we are connected now in Zoom. So in your home or in your phone, you can use internet, and you can share that via hotspot, or if you're using ISP provided router, you connect to that router. So these all become local area network, whatever devices you have in home. So uh, it could be a smart light, a smart TV, or any other smart IoT devices, and all of your laptops, computers, and mobile phones. These are all connected to your network that comprises, that constitutes what LAN is. It's local area. It's local to a specific entity or specific person who has access or manages all the devices. Now, when it comes to MAN, consider this into a larger scale, where several such lands are interconnected. So this usually happens at the level of organizations, corporates, or companies who have multiple offices or branches across a city. That's considered as a man. Now, again, a man, if you broke into individual nodes, they're nothing but lands. There could be 10 to 100 computers, printers, which are all connected via a common network. Now, this individual LANs, when connected through a means of network provider, who provides like a kind of a least connection between these LAN networks for a enterprise or companies, that constitutes MAN. Similarly, if a company is extended or it's geographically located at two different states or countries, and they are connected via larger network, larger public network, or uh, even if there could be a dedicated network between those different MAN connections, that you can consider as a wide area network. So any company in IT or even bank systems, even if that bank is present in multiple countries, they need to be interconnected. That is done through a WAN. I mean, these are all again basics. I'm moving forward. So yeah, now coming to topologies. These are all again basics, as I mentioned. In network topology, there are several topologies. What is topology again? It's like the way those computers in single network, or the very base level of grouping, logical grouping computers consist of. When it comes to bus, it's like there is two end. Obviously, this is not widely used now, but think of it like there is an start and end of an network line, and devices are tapped into that, and they use common network backbone, and that constitute bus. Information travels from one point to the other point, uh, and all devices are likely to receive same message. That's what constitutes a bus topology. Now, similarly, there is another topology called star, where a device called hub is interconnects multiple computers. Now, each device can talk to other device in the network via this hub. They can't directly connect. They can't directly communicate with each other, but that is done via hub. Hub is kind of a device you probably have. I mean, this comes back to a real life example like a router, which also works as hub, where it allows communication from one device to other device. Though I have illustrated here with a computer, this could be a mobile phone or another IoT device, but they're all interconnected. Now, similarly, this star is now, is extended to another level, which is known as extended star topology, where multiple hubs are connected with a common hub, or the switch, or the router. There could be multiple network devices, which we'll come to discuss later, but they are, they make possible to make connectivity between multiple group of computers. Now this is group A connected with its own hub. Now this is group D connected with its own hub. These are interconnected with a common device again. So this device obviously will aware of other network hub. This specific, sorry, this specific hub might not aware of the end computers, but it will be aware of the hub which it is connected to directly. Now, this hub on the group A would be aware of these devices because they are the at the end level. This device need not to be aware of end computers or the end devices. Yet, communication is possible by the means of this topology. Cool. Now, Yeah, going back, any questions in this section?
Hello. Uh, So I had a question, like in the previously described man and land. So can we say that if computers are connected
Lakshay,
to
Lakshay, sorry, your voice is not so audible. Not sure, is it only
like,
for me?
hello,
Yeah,
is it audible now?
still could be better.
Wait, I'll try to reach.
Yeah, can you speak up again?
Hello.
Yeah,
Yeah, I was asking, can we say that if computers are connected to each other via LAN, it would be a man connection
computer connected via LAN.
to each other in a cluster?
Uh-huh.
Can we say that it is a man connection?
Uh, I mean, it's more of a logical segment, right? So if two devices are just connected via LAN, they are just in a LAN. If such, like, computers which are in one location are connected with another set of computers which are in different location, then you can say it's a again, they need to be, like, distantly close as well, say within a city.
Okay. Okay. Got it.
Now, when such city level connections happen, or city or state or country level, then that's a wide area network. For example, internet is itself a wide area network. That's why we say it's a World Wide Web. But basically, it's an infinite number of computers connected. We don't know how many computers are connected to internet, but they are all connected,
Right.
and we say that's in a wide area network.
Yeah. Right. Okay. Thank you.
Oh, yeah. So now let's go to the very basic uh, or the key principle in the networking, that is OSI model. OSI stands for Open Systems Interconnected. So obviously, at the start of all the networking development or internet development, uh, there needed to be a standard. Like, obviously they were not aware of how things gonna extend. They, when OSI model was developed, they were not aware of, there will be a time when we'll be having 100 different devices in a single home, like, smart lights, smart bulbs, which I already mentioned, could exist. They were not aware of this, but they lie down this, fundamental principles which are still being referred to. So that's the level of thoughts involved in implementing this model. So this is again like a conceptual level. Each layer we don't refer and use on a day-to-day basis, or even at our work or any other networking implementation, but they will help you to understand at which level or which layer we have uh, which device, or how they are connected, or how they are working, and if at all, if they are having any issues, which layer it is, and how they are how they could be troubleshooted. And each layer may or may not provide a, like, complete list of protocols, but they are defined at a different level, which I'll show you in next slide. But yeah, so these are the 7 layers. Whenever we talk about layers in networking, it will be referring to this. You may come across someone in the Slack community referring to layer 2 or layer 3 or layer 7. Those are the important ones which are uh, referred in our Kubernetes development. So layer 7 being application, that's the, like, what by means of we are currently connected. Say Zoom, you can say Zoom is a layer 7 application. that is connected again via multiple layers in the background, which we are not exposed to. Uh, but Zoom takes care of within its own network. So similarly, there will be different operating principles at different layers, which we'll uh, talk about in next slide. Now, why this OSI model was required? As I mentioned, to standardize things develop very quickly in the technology world. Obviously, there needs to be of some standard, so someone can refer to that and then implement their own use case. And there needs to be compatibility or interoperability between multiple devices or the way they are connected. Say you have a router at your home that you need to connect to a laptop. Now, laptop is not aware of any other device called router. It's just a computing device. A router is again, it has its own responsibilities to carry out. They don't know which device they are connected to, but the means of network ports, they make possibility compatibility between these two devices. So laptop is connected to a router, say in a old world, we have physical a cable, which is known as Ethernet cable, which is a standard coming from a physical layer. And you connect those two devices, and then you run a application, any website, or like as I mentioned, Zoom, that goes on to application level. So that's how it's all interconnected. Now, this reduces complexity. Once you have model laid out for any development, you will have a view. Okay, I need to develop something in a specific layer, and I would need to understand underlying principles of it and see how I can use it or develop it. That's how it reduces the complexity. Now, obviously, what we are now doing is learning about this, so it simplifies. We can't just start by entering a website in a browser and try to understand what is networking. It's impossible the way it works. So you need to have a model to refer to, and that is what OSI model is. With that, it's easy to understand how things work. There is obviously, I'll share this link. There is an analogy of if you are one who likes pizza, you can understand what is OSI model with reference to a pizza delivery. I can share this link, but it basically takes care of explaining you what is OSI model, what are the different layers uh, with reference to you ordering a pizza and that pizza being delivered to you. Cool. Now, this is huge table. A lot of things which you might, might be confused with, and you don't need to worry about those acronyms. You will understand, or you might know some of these already by the level of information you already had with your education or with self-learning. Now, so this is divided into layers, layer number, and what are the devices referring to those layers, and what is the data unit for that. When we say data unit, a data can be like again bits and bytes. One data, one say we refer to packets in networking, what that packet consists of, and what other measures of those packets. And then we can have a look about implementation and protocols. This is just a graphical representation or any examples for that layer, and some of the reference to the text in here. So now let's talk about layer 7, and we'll go to the bottom level. Layer 7 is application, obviously, and the device which can be referred to this as firewall. Again, you may need or not need firewall, but is one of the example device which operates at this layer. Now, implementation and protocols. So you might have come across DHCP, DNS, FTP, and definitely HTTP, and even SSH if you are connecting to a Linux machine. So these are the protocols which operate at layer 7. Again, how they operate, how they work, that's a different concept and different you know a different level of session, which we may go in deep, or I guess that we can leave to individual. But consider whenever you hear DHCP or DNS or any of these protocols, they are referring to layer 7. Obviously, this will need not to be on top of your head all the time. You can anytime refer to OSI model in Wikipedia or any of the network providers. They will lay out which are all the protocols part of each layer. Now, what this layer is responsible for: resource sharing. We are on a computer, as I mentioned, Zoom, which is sharing a resource provided by laptop. The same laptop can provide resource to some other web application. Say in background, I'm trying to access another website. That is again using the same laptop, same network connection, and that is possible because though laptop has its own capabilities to provide operating platform for operating system, and operating system has some of the capabilities, those are all again interconnecting to some of the networking when you are trying to access the information from internet, and that's happening at the application layer. So some of other examples are remote printer access, file access, directory services. uh, File access as in FTP, or if you're trying to access a file from a network, accessing the same file on computer is just a system level file transfer. But you're trying to access a file from a different computer in network, that's very much uh, uh, accessing a remote file. Again, that could be in your local, or you probably trying to access a file from Google Drive or Dropbox. That's also remote file access. But again, they get converted into different level of abstraction. Say Google storing data in a file format, but when it streams to your browser, it is coming in a streams of packets. But again, when you see in your website, it's like another file. But at the end of the day, it's all binary. So that presentation or application transformation happens at this layer. So now a presentation layer, that's the layer 6. Data unit is still a data. Now here you see some of the protocols like SSL, Kerberos, WPA. So these are all mostly surrounding to security or encoding. Why we need encoding? Obviously, this again goes back to accessing information via internet. So say something which is stored in Wikipedia is a public information. No one needs to encrypt that. That's because that's a knowledge that needs to be shared across everyone. But at other end, say you are trying to access your bank account, online banking, which is something private. You don't want that to be exposed in internet. You don't want someone else to use drop or have access to that information. Though there are mechanisms like username, password, multi-factor authentication, etc. There are still chances of those information being um, you know traced or captured by third party or man in the middle, and they can misuse it. They can whatever what we call generally hacking. So to avoid that, there are some measures which are encrypting at the terminal and decrypting at the other terminal. This also means I mean, irrespective of security, there's also an encoding involved here. For example, say you take a picture, which is now a digital camera, which converts that picture into JPEG. JPEG, or uh, it's a format for image, one of the format for images. There could be multiple number of formats you might know, like BMP or GIF. or PNG. These are all different format of encoding for image information. Now JPEG is another format, and that is stored in an system again with binary or with base64 encoding. But when decrypted, you will see the actual picture. When it travels via this layer, obviously, this layer is what responsible for encoding it to a base64 and transmitting it to a server. So by doing that, it is able to probably compress it as well if it needs to be bandwidth aware. If you can't say there is an 48 megapixel camera which took 48 MB of image, I mean that image is of 48 MB, you would definitely want to reduce the size before sending it to a different network, so that it don't take it doesn't take longer time to upload that file. That happens at this level where data compression and then the encoding happens. Similarly, at this layer, there's character set or character code translation as well. Say we have now, I mean, very uh, layman example, this could be emojis or converting some of the Unicode characters to human readable format. That all happens at this level. Again, this layer is not doing anything. There are some applications which will be taking care of those functionalities. But in a logical grouping, it happens at the presentation layer. Yeah. Any questions for these two layers? Okay, silence is golden. Cool. On the layer 5, we have session layer. Now, this is like, some of the very underlying operations which you may not be seeing. This happens with network devices to open a connection. When we say open a connection, right, there could be multiple things. Say a client computer trying to connect to a destination computer. It needs to say who it is, acknowledge its identity, and then pass on what's the request it needs to what's the request it needs some assistance from the target computer, and then perform some security validation, authenticate, understand how this computer is eligible to connect to this computer, the target computer. This all happens at the session layer. There are again different protocols used here. Even I am not aware of most of these protocols except TLS, SSL, and the sockets. Similarly, one of the example I found was RPC. This is something programmers or most of the software use, something called a remote procedure call, meaning say you have a some code running at your side, as in the client side, but that code also refers to some of the functions stored at the server level. There are scenarios where these are required, where you do this remote procedure calls. You don't want to execute that function or that procedure at your machine, but that needs to be executed at the server level. So you send the parameters for that function to a server, and server does the calculation uh, with whatever resource it has, and then sends a response over to you. This all happens via network, and this is provided by means of layer 5. RPC is one of the example which can be related to this. Now you could see in Kubernetes world there is an reference to the gRPC. So that's at the layer 7. So RPC is extended to gRPC. Now there is no specific expansion for the G. I have heard G stands for something every release. So that's at the gRPC level. You can find more about gRPC. This is also an open source, solution. Should be available in GitHub, if I'm not wrong. But yeah, so you can link this, right? How they get transformed to different layers. RPC is at layer 5, but gRPC is at layer 7. That's an extension. I mean, anything you try to develop may not need to fit into one single layer, that can augment into multiple layers. Similarly, a transport layer, this is the uh, place where, like, uh, whatever we say, data is transformed in packets, and those packet consist several information. That message fragmentation, segmentation happens at this level. So protocols at this level are TCP, UDP, and SCTP. I'm obviously not aware of these three, which anyone can try to find information later. But TCP, UDP are the most important protocols. Again, between TCP and UDP, there is an very clear segregation when and why we need to use TCP and when you don't want to use UDP, because TCP provides some control, some security, which UDP doesn't. It's more like, TCP knows where the information is coming from and where it needs to send to. UDP is not like that. UDP is like, it just knows where the information is coming from, but it just broadcasts that information to every devices in the network. So UDP is less secure, but can be used for some of the broadcasting services, which need not contain, must not contain any sensitive information. So as I mentioned, message segmentation, fragmentation happens at this level, and even session multiplexing. So say, there's obviously, whenever we refer to information sharing in internet or networking, that happens at a larger size. It's not a 1 byte or 2 bytes we are referring to. It's like, uh, megabits or gigabits, and they needs to be um, sent in a way, we don't lose a packet, or we don't lose a data, or data doesn't get corrupted. So transport layer is responsible for that. Now, layer 3 is network. This is the, like, I would say, one of the very essential medium. Connecting all below layers with the upper layers, kind of a medium, or the bridge between all other layers. So through this, what we do, most of the time in the internet, like, accessing a page, your local computer doesn't know where that website is located, but is still able to get you that information by means of, underlying devices, like routers, gateways, and there are some other concepts like domain naming systems, and they all come into this picture. Now, apart from IPv4 and IPv6, there is an IGMP protocol as well, here, ICMP. So again, some of the key protocols which we would be discussing in detail is IPv4 and IPv6. Again, between these two, IPv4 is widely used, and we'll discuss more on this later. So at the network layer, things get into kind of a in a structured manner. That's where source and destination is clearly defined, and data is transferred from source to the destination. That routing happens via this. Now, data link is at the very base level, uh, closely associated with MAC address. I believe, this must be obviously basic in any of the networking topic. So you would have come across MAC address, IP address. So MAC address is something related to physical device, though that that can be virtualized as well, but it's very much required for any two physical computers to connect or communicate, or for any network. So MAC address is usually provided by the manufacturer of the network device. It's hard coded into the networking adapter. Even if it is a device which uses Wi-Fi, still will have an MAC address hard coded to that. It's at the factory level. You can't. I mean, I remember some of the MAC address can be modified after you purchase from a provider, but it's usually not editable by the user. But in virtual, computing, obviously will have that control over defining the MAC address for yourself. For example, if you are, if any of you guys have used any of the Hyper-V devices, I'm using Hyper-V provided by Microsoft Windows. So that provides an option to declare your own MAC address for an VM, and you can mention your own digits or alpha numeric digits for that MAC address. Now, why this is required? Obviously, to communicate over a network, you need to know the address. So I guess I forgot to mention this, but while understanding networking, one can refer to example of how the post office system works. Like say, for example, person A is sending a letter to person B in some location. He just provides a letter with source and destination address in case if letter needs to be if letter can't be delivered. So source is important and destination is, that's the very basic essential for sending message to someone else. So you don't worry about how it works from your own area of post office to the person B's post office. You are not aware of the post office. You are not aware of the people working in that post office. You don't need to worry about the post box. All you do is enter a message, secure it with envelope, and put a address and put a stamp. So these all constitute, at this level, um, uh, layer 3 level where you mention the IP address and the envelope consists the message. Though you can have inside details about whatever message you put in, but the outside what you put in, destination address, that's what matters. So that address you can compare to IP address and MAC address. It's again a very loose comparison, but that something helps you to understand the overall networking. Now, when it comes to physical layer, this is the a device or the very basic hardware which makes this connection possible. As I mentioned, a network interface card or the Ethernet port on your laptop that consists of some chips which we can't see without opening a laptop. Those all perform an operation at the machine level. They do their own level of data encoding, and they transmit data into bits, and even they convert into electric volts, which is understandable by transistors or whatever our CPU consists at very low level. So this is possible. These are all augmentation. What you can see, if you take a root from your laptop, say you enter a website address in your URL, that's obviously converted into zeros and ones at computing level, and then to go outside your computer to the internet, it will travel via Ethernet port or the wireless device, and then it connects to the router. There can be switch in between if it's a physical wire. Otherwise, it's just a router. Again, router, it can be directly connected or via wireless, and then that's transmitted via transport layer, where it takes care of, as I mentioned, message segmentation and the fragmentation. Say it's just an information sending to Google's website, where obviously you will have fast authentication like a Gmail username or password, and then that's stored into a presented into another user who is using Gmail, who is also authenticating with its own credentials, and he reads back this information in the same way. So it's very high level how these layers help, but each layer constituting implementation protocols what defines how network devices communicate with each other, how they represent data without losing the information, and what happens if message fails in that case. And the applications at the layer 7 level will be able to take care of that failed messages. Either it can have an option to retry, or it can have an option to provide more information why the message transmission failed. This all happen at layer 7 level. Cool. Any questions so far?
Hello. Am I audible?
Yeah.
Yeah. So I'm new to all this, so I might not be grasping everything. But what I wanted to ask is, like, how are these layers interlinked? How does the concept of layers come to play here?
So, I mean, layers, you don't refer to layers in everyday use case, but, in our use cases, these are all defined by different applications, different devices, different, even invisible devices at the remote computing level. So, say, at the layer 7, obviously, what you have at present is, a browser or a application which connects to internet. But that again has its own capability of how it can convert or secure the data. So these all comprised of one application you can think of, and that application connects to a remote server via transport layer with use of Ethernet port, your router at home, and then makes a connection to the target server. So these layers are not directly referred in every day-to-day life of a networking site, but they
Right.
are to explain you how each layer is defined and how those protocols fall into different layers.
Okay. Okay.
It's very theoretical, what I could say. It's like kind of a rule book or a model book, a blueprint. You can't just construct a house with blueprint, right? You would need a means of like other physical things like bricks, cement, etc. So, and then you need constructors to construct that home. So, but blueprint is very much essential to construct a home. That's how this OSI model is like.
Raj,
Got it.
Raj,
Yeah.
would this be a good time? I want to make some comments. Would this be a good time, or do you want to? Do you think there's a better time later for me to make?
Yeah, if it's helpful for this session, definitely go for it.
You decide, because I want to. I may take up to 10 or 15 minutes, or maybe even 20 minutes.
Okay, so this being a Zoom call, I guess there is a 40 minutes of limitation. If it disconnects, we'll reconnect again. But yeah, go for it.
Okay. So everyone can hear me?
Yeah, you're audible.
Yes.
Yes.
Okay. So first of all, thank you so much, Raj, because it's such a wonderful piece of information. Now, the comment I want to make is I want to connect this information to where uh, we came from where we came to this with the example of the ingress controller, right? Um, so keep asking questions if you can't understand, but I'll try. I'm going to say something which you must which you all must think about. Okay. Um, in the example of typing curl command, which you saw when you were doing inner sessions, right? What occurs is this. Curl is a command I type, which means curl is a binary file or executable file or a script or something like that. Whatever client I use to send a HTTP request or a browser software like Google Chrome or Firefox or Safari, that is it's an executable, it's binary, it's in the operating system of Windows, Mac, Linux, curl is it's there, right? So what occurs when you do that is there's a piece of text it takes, right? It takes the name of a website or what I was doing, www.dev or whatever. Now, for that to reach a Kubernetes cluster that is on Raj's server somewhere else on the internet or in cloud or even google.com or Yahoo, wherever, right? Uh, it's a simple need based thing that is happening, the requirement, okay? Requirement. Because you have an operating system, and because the operating system talks to the user in English, it takes input in English, okay, in English alphabets, okay. Does this make sense? This much, okay.
Yeah.
Yes.
Anybody who doesn't get this part, anyone. Okay, everybody understand that when I type curl, I give input in English, which is what the operating system is designed for, to interact with the user in English. Now, this is such a beautiful graphic that you see of the 7 layers. You can associate the curl with layer 7 on top application. Okay, because it's the application processing the data which has to go between two computers from a laptop to a Kubernetes cluster somewhere else, or even on the same laptop, doesn't matter. But it's still two different destinations or two different locations, two different IP addresses or two different interfaces or whatever. It's two different things from one to another and from another to back to the first one. So application layer you can consider as that. Curl takes input as text. Okay. Now within application layer itself, you see the diagram, it says DHCP, DNS, FTP, HTTP. We can't talk about all of them, but at least with curl, we did HTTP, right? So the context being, imagine if I type, Raj, go ahead, can you share your screen and share a terminal?
Yeah. Just a second.
You have a cluster running, right?
Yes. I'm
Okay.
just trying to connect as well. Just a second.
No need if you don't have a cluster, also it's fine. Just want to see, talk about the curl thing. So guys, make a guess. What I do in curl will actually go through this workflow from application to presentation to session to transport to network to data link to physical. Okay, this is the context you need to understand mostly from these sessions. And if you don't understand this concept, you can't actually work with network related projects. Sir, while we wait for Raj to share his terminal, the point I'm trying to say is, with curl, if I type a long sentence of 10 characters with spaces, curl, hello world, how are you? In front of curl, space, hello world, how are you? It will not work. Now, please unmute and say yes or no. Do you understand what I'm saying? If I type curl, hello world, how are you? With spaces, will it work? Or in the browser, in a Chrome browser, Firefox browser, on top in the address URL, where you type google.com, yahoo.com, github.com. If I type hello world, how are you? Does it work? No. Does it work?
No.
No. Everybody say yes or no. Does it work?
No.
Okay.
No.
Why does it not work? Why? Now just take a wild shot. Just take a wild guess. Why it does not work?
Because hello world is not a domain.
Everybody take a guess. Everybody take a guess. Tell me why it does not work.
Yeah, it's not in a particular format. We try to give the input.
Yeah. Other people
Uh,
talk. Why other people are not talking? Somebody talk, please. Everybody talk. Because
Because
if everybody doesn't get it, it's not going to help really, because that's the juice of this session.
yeah, so I was saying that because we are adding space, so like we should
Okay.
just send one address and we are sending multiple words.
Okay. So again, we're still back to after 2 weeks of sessions, we're still back to the same concept that we're not getting feedback from everyone. Everyone doesn't want to talk; they want to keep and listen. So that's fine with me, but it's not going to help you. Take it as a feedback from me. The point I wanted to get across with this graphic on your screen and the curl example was, right then and there, if your objective is that you want to send something from one place to another place, computer wise, network wise, okay, not physical Amazon wise, okay, from one place to another place. Raj, just go back to the slide, go back to the, okay.
You want to see
What I'm
the
trying to, yeah, got it. So what I'm trying to make you guys see very, very clearly as per this model OSI in application, curl is the application and it is bound by HTTP. You can only provide text as per these protocols to the application that processes it. Okay. There are many command line tools and GUI tools for FTP. Okay. And when you switch on your computer or when you bounce, put your Wi-Fi on and off, you get an IP address. If you switch off your network Wi-Fi interface, you don't get an IP address. So that is where DHCP, Dynamic Host Configuration Protocol, dynamically, not statical, dynamically, you get an IP address, you get a route, you get how to connect to which network. That information comes over the network from the route. So that is that DHCP. And then if you type, then if you want to go to yahoo.com is a name, okay? But on the computers, they don't understand names and words, right? They understand IP addresses or they understand more binary addresses. So converting a text name like yahoo.com or google.com to an IP address is DNS, which we all know, right? But that is part of the application layer protocol is what I'm trying to make you think. Okay, that occurs. So it means when you troubleshoot applications, when you troubleshoot code, when you troubleshoot any issue, or when you work with it, you need to understand. People will say, okay, layer 7, this is a layer 7 thing. It means some software are doing layer 7 thing. Some softwares are doing layer 4 thing. Some software doing layer 3 thing. You understand the differentiation now?
Yes.
Yes.
Okay.
Yes.
Okay, so for those of you who have at least touched cloud, okay, one example you will see is that some load balancers will work at layer 7. It means they can play with the traffic of HTTP, okay, and HTTPS and IMAP and all those protocols, okay. But if the load balancer is operating in layer 4 mode, okay, you cannot configure it for HTTP related um, tweaks or changes or whatever. You cannot do it. That is the relevance. You get it?
Yeah.
So some things work at layer 4, some things work at layer 7. That's the context of this chart. Okay. And if you completely not never heard of this and how this works, think about this. What happens is in curl on my laptop or Raj's laptop, we type curl something www.yahoo.com. That is application layer in curl. Okay. It is an application written in C or something. Somebody other have Python libraries, doesn't whatever language, but it is bound to the HTTP standards or HTTPS standards. It takes only those inputs, processes only those inputs, and it can render only that kind of work. Okay, that is application layer. Got it? But then if you connect to HTTPS website, okay, there is a certificate involved, and that is the presentation layer. It means that is how the data, if I say hello world or give me yahoo.com index.html page, then it gets presented over SSL. It means presented, a certificate is used to encrypt that. Got it? In application layer, I will request for that. Like I will say https yahoo.com. It means I can formulate a request. I can create a request. So that means I'm working at application layer. But when the actual encryption happens, that is presentation layer. Okay. Now, there is something called session layer. Okay. What is session layer is basically many laptops, many cell phones, many people connect to google.com, github.com, or the trillions, zillions of websites and locations, right? There is only one IP address, correct? Uh,
Yes,
Raj,
yes.
that box is overlapping the slide. Raj, Raj,
Yeah, is it okay now?
mm, yeah, the screen sharing went off.
You able to hear me?
The screen sharing is completely gone. Uh,
Okay, just a sec. You able to hear me, right?
yeah, I can hear you.
Yeah, just a sec.
Hey, long in the meantime, I have a doubt if you.
Yeah.
I have read at places like layer wise access is given. Like somewhere you have layer 4 access, somewhere you have layer 7 access. So what does that actually means?
Where did you read that?
I was going through some of the for those reverse proxy and all those things you mentioned about in the initial days, like ingress and all those. I was going through some of the blogs. So there I read about these things that layer wise access is given, and like there is something the layer 4 and layer 7 access, like that was quite prevalent in those parts. So I didn't get it, like, what does that mean? And even how do you connect with, like, you have layer 7 access, but you don't have the like all the below layers access, and then like how do you manage things, with one layer access and no layer other layers access?
Yeah, that is what I'm talking about. But it takes some time to relate to different wordings to this slide. So
Okay, okay.
I'll try to explain. Okay,
Yeah.
that's why I wanted to take a few
So
minutes.
can you see the screen now?
Okay, yeah, I can. So so remember, guys. So there is only one IP address at yahoo.com. Usually, let's say okay. In an example where there is only one IP address in one place, one destination, and 50 people connect to the same website, right? So how the server will manage all 50 different uh, browsers, laptops, or cell phones connecting to one single website at one IP address. Okay, that is the kind of concept that is handled at session layer. So it means there is concepts, there is configurations, there is workflow, there is actually code, okay, in sessions. A typical example for session layer, why I wanted to show was okay. So Raj, is your terminal working now? Will you be able to share a terminal?
Not yet. I'm just need to restart it. Few more minutes.
Okay. So you see on your laptop, if you type if you, when you use curl or browser, you will always see http or https there. And in your mailing software, if you have a client software like Outlook or whatever that is using IMAP, so explore and read what are these different protocols. It is actually a whole expertise world. People have to understand what is all these different protocols and how they work, like in a software, not as a simple user. If you are going to support and contribute and help somebody troubleshoot some problem with these, okay, each one has enough reading material you can read. But the idea I wanted to kind of get it very clear for you to think about and apply whenever you do troubleshooting or do contribution anywhere is there is software and limitations and design that curl will can do http https or some limited protocols. When a network interface comes up, it looks for DHCP IP address for Wi-Fi from the router, that is the DHCP protocol. Okay, when you type a name either in a terminal or in a browser, that name gets translated to an IP address. That kind of translation is the DNS protocol, and that is all of these things are application layer. Okay, that's how you think about it. That's how it works. That's how you troubleshoot. That's how you deal with it in your code also. Okay, and then comes presentation layer, which is SSL, encryption or certificate. Example. Okay, session I told you, one server actually handles 50. How it handles? Read about it, understand it. Basically, it's a IP address socket pair that happens. So on your laptop, if you do some commands, netstat type of commands, or SS is a command on Linux, you will see a long list of connections established, connections not waiting, and all that kind of different states. But all of these are basically pairs of IP address number colon socket. Okay, so on one TCP IP stack, you open different sockets, and that is how you manage different sessions. Okay, there's one example of session. Got it? Make sense? And you getting just how
Yeah.
you think about these layers? You understanding?
Yeah.
Also, I just wanted to add here. We'll go
Yeah.
with some of the networks related CLIs, and we connect back to these layers, 7 layers in that session. It's
Okay.
as I mentioned, right? It's a huge session. We probably need to do it in a different slots, but yeah,
Okay.
I'm planning to cover those CLIs, and we can connect to these layers that time.
Makes sense. Okay, awesome, awesome. Then let's stop here. I'll stop here. Let Raj continue. But that is the ultimate goal you need to get to. Thank you. Okay, Raj, I'll stop.
I had another doubt, like
Yeah, yeah,
long yeah, like you said me like this, like IPv6 and all those things we like disable while hardening our OS and all those things. So if we are trying to harden a layer, suppose a layer 3 or layer 4 in this OSI model, so do we need to take care about other levels of if I am layer 4 is secure, do I have to worry about my layer 7? Or if layer 4 is secure, it automatically sets that all my upper layers are secure?
Raj, you want to answer that?
yeah. So is it Dave who asked this question?
Yeah, I asked this
Hey
question.
Dave. So I mean, now it goes back to this layers, right? The uh, device you develop at, I mean, you can't have some software application at layer 3. Okay, so it must
Yeah.
be a network device like a router or switch that can be secured in its own way. For example, Cisco secure its devices with, again, some level of admin control, uh, and it also will have some of the security suits or the cipher packets installed. That all happens at the device level. Now the application you can develop and control is at the layer 7. So say you create a web application or a software application which connects over internet. Yes, there you can have control to harden it by the means of same encryption and decryption methods, also using uh, KMS keys, or you can encrypt using single sign-on authentication. Also, for transferring over the network, you will definitely use SSL certificates over HTTPS. So it's not you can develop something at layer 3. No, you will be developing your applications at the layer 7, and they go on onto the already defined network route. You are not going to develop a network, a dedicated network or dedicated networking device. You will be developing an application, a software application which operates at layer 7 but connects to all of the underlying architectures uh, by the means of networking already. You don't need to specifically create a code for connecting to network in it.
Okay.
Does that make sense?
Yeah, yeah, yeah. Also, like as much as I remember, as I was citing the example, like I disabled this IPv6 in my system.
Mm-hmm.
Okay, so I was saying, if I authenticate in one layer,
Mm-hmm.
do I need to take care about authentication in other layers? Like, do the like all these are connected or these are independent? Like, I need to have authentication at layer 6 as well as layer 5 as well as layers 4,
No, no,
all the layers. Yeah,
no. You
could
don't.
you
You
throw
don't
Deva,
some
need to
light on that?
Deva,
handle it.
wait, Raj, wait 1 minute. Raj, so what Raj is attempting, or I got the messaging that he's introducing these concepts now. Okay, now there are 14
Okay.
people or so many people. Not everybody will have all ideas about all of this. Okay, so the answer to your question is that it is not. There is nothing generic like that. Okay,
Okay.
the answer to your question actually can only come up if you deep dive into the actual code and the actual nature and whatever. See, it's very complicated. Okay, what you
Okay.
send over the network. Okay, some information will apply at layer 7, some information will apply at layer 4. The information that is relevant to layer 7 is not relevant to layer 4. So if you're inspecting layer 4 for security or interruption of some kind or rerouting or change or whatever, okay, and actual surface area of the attack is layer 7, okay, it is completely different mismatch of what is being done and what is being expected. So let's not go there for now.
Okay.
Talk to me, I'll explain. But in this session, I just got the messaging. I understood the picture that we're getting introduced to all of these concepts. Let's get introduced first. Okay, let everybody get
Yeah,
on the
yeah, yeah.
same page.
Cool, cool.
Then
Yeah.
later, let's deep dive into so many, because this is a whole lifetime itself. Actually, Cisco has a certification just for security. Okay,
Yeah.
Yeah.
and those of you who know, there is actually a CISSP kind of certificate. Like if you do that certification, you'll probably spend like so much hard work you have to do to study and pass that security certification called CISSP and all that, and um, that it actually takes up organizations actually take up professionals with that certificate as a full-time employee, and he only does that one job, security inspection, and he'll actually not do job also. It is just his knowledge and awareness that he will watch and inspect. There will be actually junior engineers who will implement the software and commands or whatever and configuration and maintain it. Okay, it's that complicated, security, and so it's actually whole world. And this is the world. This is kind of the stuff that is made up of the most unmanageable and you know unconquerable thing. All these country attacks between countries and countries and hacking and all that. It is that level. Okay, so
Okay.
the deeper you dive into the actual content of the packet that came in and the IEEE standards of that layer and that hardware and that software and that stack. Okay, you're never going to conquer it. It's a whole world. So in this session, try to get introduced and just try to map
Yeah.
your information and awareness to different thing. I just got curious that I want this concept that you at one place you pack it. When I type curl, I pack things. Okay, I type
Okay.
something in English. That English thing gets encrypted with a certificate. It goes down, then it goes down, then it gets an IP. So it's like a onion, peel thing. But except that it's like a computer doing computer creating an onion. Okay, inside will be my hello world, or my inside my curl request. Okay, on top of that curl request there will be a it's like it's like taking multiple layers of paper cover, one on top of each other, one on, just like Amazon ships or couriers ship one cover inside another cover, one cover inside another cover, and so on. Right, it's like that concept I
Okay.
wanted you to understand. There is English text. That English text is encapsulated. It's called encapsulation, the word. Okay, it's encapsulated with the next layer information. On top of that there is next layer information. On top of that, finally, when it comes to layer 3, there is encapsulation of IP addresses, which means this is the source IP address and this is the destination IP address. That both those things are put on the packet which I'm sending from one computer to another computer. And then it drops to MAC address, which is the network card, Wi-Fi card or physical network card. It's called MAC. Find out what is MAC. Okay, it's called
Yeah. Yeah.
layer 2. So that goes, that's like one more paper layer on top of that address. Okay, one more on top of the previous package. Then it is just dropped to the physical copper wire or all the interface. When it arrives with all that information, it's like the address on a letter or on a courier, right? It arrives with that. Using that information on the packet, it is sent through from your computer to your Wi-Fi router to your nearby Wi-Fi hub or whatever your ISP providers. From that one ISP provider to another ISP provider, from another ISP provider to outside the country, from outside the country to across different continents, and across different continents to again back to in America or somewhere or Europe, wherever the website is. In website, then through another ISP provider. Okay, it's all in that information on. They keep putting that address patch on top of it, and that is what routing is. Okay, so that is what is this
Okay.
7-layer thing about. So finally, it will arrive at one computer on the copper wire, and because of the MAC address, it will get picked up. Okay,
Okay.
then
Okay.
the MAC address will be unpacked. It is called the encapsulation is reverted. That computer will remove the MAC address thing. Beneath the MAC address, then we find IP address. Okay, Then next layer will remove the IP address thing. The next layer will remove session, TCP, IP, SSL, all that. Finally, the curl or the netcat command or server running at the other end will finally get the packet without IP address, without it just get that raw packet with that information, right? And because it is session layer, it's an application, it understands. So other sessions cannot understand how curl has created that. Just like JSON is a format, just like XML is a format, right? It's every application will have its own format. It may be JSON, but then which field comes first, which field comes last, all that is decided by that application. Then it will unpack that. So at one end, you pack within one paper, inside one paper, inside one paper. At the other end, you unpack, you peel one layer, one piece of paper on top from top. Finally, the packet reaches the server destination. Okay, that is the concept you have to understand from this.
Yeah. Okay.
Okay.
Got it. Clear cut idea. Thank you.
Okay. Continue, Raj. Sorry.
Yeah, notice. Thank you.
Okay.
Yeah.
I'll drop off. Okay, I need to go.
Yeah, sure. Okay, later. Cool. Now let's talk about network protocols. I guess, as Long mentioned, right, it was only introducing to the concepts here in this OSI model. This is again, it's kind of a blueprint. It's a model which helps us to constitute application or device at a different layer. As I mentioned, you will not be developing application at specific layer, but your application will be connected to different layers by means of an existing network, existing device, and some of the existing libraries when it comes to software level. So now within network protocols, again, why we need protocols? Obviously, just like how we need a model, right, to constitute any network communication. So there needs to be set of protocols or the rules standardized to communicate in an this enormous network. So between two people, obviously, you need to know that person's language, the way we communicate. We just can't talk in a way which would hurt someone, because there is an when it comes to humans, there is an element of emotions, there is an element of politeness. We add all these protocols, right? And our communication differs how we talk in home and how we talk at office, and it could be different, when it comes to conference, right? So similarly, when it comes to communication in network as well, it differs. There are protocols, different protocols, and applicable at different layer, and that protocols are broadly classified into these three. Uh, I hope you guys can still see my screen. So one is communication, and the second one is segment. The most important one is security protocol. So, again, you have seen these protocols listed in OSI model. Now you will see these listed into these three classifications, right? Those protocols you might have already come across. Okay, I'll show you what are those. Say now when it comes to communication protocol, obviously HTTP, TCP. I mentioned about UDP, which you may or may not be aware of. Then there is IRC. So what these are for, these communication protocols are for. Obviously, for these are the main protocols which required for any network to function. When we say network needs to function, like two devices communicating, two or more devices communicating. If we are saying they are communicating successfully, means these protocols already are applied. If any message or any device doesn't satisfy this protocol, they will not be part of any communication. So very existence of computer networks depends on these protocols. I mean, again, not any one. It's combined mixture. It could be selective of some of this. Not every protocol will be required for specific communication. Now this applies to both hardware and software. So one of these, obviously, HTTP is hypertext transfer protocol. What does it mean? Through web, where we transfer most of the information today. That's all converted to in this format, and it is sent over a IP protocol. That's a different protocol. Okay. Now transfer control protocol. That's what takes care of message fragmentation, as I showed you, and some of the security is applied at this level. UDP, it's a non-secure. It's mostly used to broadcast. For example, uh, you might have heard about the VPN, probably using VPN. So when it comes to VPN server, if that's configured within a local area network, VPN server broadcasts available IP address to its clients, yeah, on an UDP port, because there is no harm in saying, okay, I have these IPs in a local network, and that VPN clients, right, they will try to say, okay, I'll use this specific IP address, assign it to me, and then VPN server assigns it back. After that, it controls all the messages via TCP, HTTP, or different protocols. It won't use UDP for message communication because VPN is very much required for the security. But VPN server broadcasting, list of available IP address, that can be done in UDP. So now IRC, it's not widely used, and it's internet relay chat. It's one of the example. I think it's probably based on is Apple's iMessage that uses IRC. Google is also introducing IRC in their messaging application in Android. So it basically relay chat. It's a connection is open between two messaging applications via network, and you'll be able to see if that person is typing. There's active session open. Whenever we say active session is open, you transferring a message via post is an offline. You don't need to have a dedicated session open for that. But when you are trying to call someone, you will be having an active connection open between you and them, right? So if it's a telephone, a landline, or even mobile, there is an active communication line open between you and the other person, so that you can talk in real time, right? It's not like you say hello to that person, like how it happens in the walkie-talkies. You say hello to person, and then you terminate the connection, and then the other person responds. It's not like that in the mobile or a phone connection. Similarly, IRC is like that in a message communication. It's an active, another example, but WhatsApp or Telegram, they work over IP. They are not based on IRC. They are based on internet. But imagine WhatsApp message working over SMS. That's what is IRC. This is again just to give you an hint like how things work, how different protocols are in place. Any question in this specific protocol?
No.
All good?
Yeah.
Cool. Now, I just want and not to shock you or overwhelm you guys in the learning process, but this is the protocol landscape. Just like you probably have seen Kubernetes landscape, how there are different operators, different providers. Similarly, networking has its own landscape of protocols. So this is in Cisco's website. I'll share this template later, but yeah, they have constituted this landscape where you could see different protocols for different use case at different layers. Okay, this is again, like as I mentioned, networking is not something which could be covered in 1 or 2 or even 1 day or 1 month session. It's a huge area of an technology. You need to go deeper if you want to see understand different protocols. You will need not to know every protocol in the networking. You will use what you need. You will understand what you need. So for some application, as I mentioned, gRPC, if you need to understand that, you specifically study that specific protocol. You don't want to understand some other protocol like MLP or PPOE. So yeah, this is just a glance, like how different protocols are outlined. Now, management protocols. So what is, when it comes to management, the very question is why we need to manage. Obviously, when it comes to any technology or any functional, right, there needs to be something to manage. You just can't let the things play without any control. You need to have some administration. You need to have some way of monitoring how the network communication is happening. That is provided by management protocols. Again, this is not the only two protocols in this level, but these are the very important ones. SNMP, as it stands, Simple Network Management Protocol. As I mentioned, to monitor the network devices, right? There's like, this is mostly on agent and server or the manager-based, management, where and actively running agent is installed across participating network device, and the network manager uh, pulls in the information to check the status of that networking device as well as the networking communication, whether their communication is secure, their communication is currently active, and what is the latency. Now, when it comes to messaging or the transfer message transfers, we need to understand what is the speed of network, right? If again, if you send something, if it reaches tomorrow, that's not valid in internet age of world. You need things to be delivered as soon as possible. If there is a delay, you need to be aware of it, why that there is a delay. Some cable, optical cable in some ocean is broken down, whole world goes into halt nowadays because we are so much dependent on every digital aspects of our business or day-to-day life. So that needs to be monitored at very low level and the high level. Say, when I say very low level, this is it, SNMP, managing at at an router level or switch level. When it comes to high level, people providing that service, say someone is providing a flight booking service, they will monitor their networking. They monitor the connection between ticket booking service and the airline service. That's an example. Similarly, that could apply, the same thing can be applicable to banks and the digital payment providers. They communicate with each other to make sure they are actively connected. Payment gateways like Paytm or even the GPay, they show the correct balance every time because they have these active sessions open, and that will be monitored via such protocols. Similarly, ICMP is mainly the to, as I mentioned, why any message is failed, to debug such issues. ICMP is used. It provides information regarding any connectivity issues. Any questions in this segment?
So like a system can have a multiple number of management protocols, right?
Yeah, it can. When we say system, right, it could be. We need to refer to like a router. It would have its own management. Again, we are not referring to the UI, which provides, say, for example, you have access to your router admin portal, right? Say 192.168.1.1. That's very private, as in very local to my network, and I'll be able to access and monitor all of the networking device, computer devices connected to my network. So underlying that router is using these protocols. They are not, directly that website, whatever portal page we see is not directly referring to this protocol, but whatever code they have, burned down to that router chip that uses this protocol. It's not something you can view at the high level, but they use and then they provide the presentation. Say again, yeah, this is the example, right? They use this protocol under the hood, but they provide you presentation layer via web UI. So that's the presentation layer, application layer for you, or the presentation layer.
Okay. Okay.
Yeah. So you guys, I mean, if you are connected to any broadband service, you must be using that portal page, right?
Yeah, the router portal page.
Yeah, the router portal page. That's an website. That's at the application level. But whatever it manages gets the information from very base network level, those transport level, data link level.
Okay. And can we say the connection from the router to our computer would be a LAN connection? Or,
It is a LAN connection. So anything from router to internet is an wide area network. Between router and your home devices, your personal devices, that's all local area network. How we can define this, how we can identify this, I'll show you. Or I can quickly give an hint. So any devices in your home network will be predefined with specific IP address in the range of like 192.168 or 172 or else 10.00. We'll come to this, why only these IP address will say whether it's local network or the public network.
okay. Yeah, okay.
Yeah. Now, the most important protocols are here, which are for security. Why security is important? Obviously, to avoid any damage to anyone's information, any organization's operation, or any misuse happening, right? I mean, hacking all can happen at different level, but to control that, to secure your perimeter, to limit the blast radius, these are the very fundamental protocols used in any of the network communication. So SSL, we talk about SSL certificates most of the time. That is, based on this protocol, where it provides a mechanism via keys or certificates to encrypt a message, and then also in interconnection with HTTP, with when it is referring to SSL certificate, it is termed as HTTPS. Same HTTP is a HTTP protocol what we saw in the very first communication protocol. It's a plain text. You can't have plain text for our personal banking or health related records or whatever, where privacy is most important. That's when HTTPS comes. That is HTTP with SSL. Secure socket layer is used, and when we say SSL is used, we are using an encryption and decryption method, and that encrypted message is what being transferred at the communication level. Similarly, SFTP is a secure file transfer protocol. So FTP is another example where it's not secure. FTP is allowed within a local area network where you are 100% sure, no intruder is able to access any of your files. But when it comes to internet, when you are using publicly available access, you must ensure SFTP is being used. When it is SFTP, obviously files are encrypted, and there is an authentication mechanism to access specific file. Then there is an authorization as well. You can control, again, this all depends on the that SFTP service provider. Say Google Drive is an actual, I mean, it's not exactly an SFTP, but it uses internet, but it provides you an access to specific files only, if some owner of that file is allowed you to do so. Say I have shared this PPT with 5 of you, and I have not shared with 3 others. Those 3 others should not be able to access this file. That is the requirement. Now, if I need to allow them to access, I need to authorize them. So that happens at this level of where you can control these. access. HTTPS is as I mentioned, it's a secure version of HTTP. With it is used in conjunction with SSL. Obviously, everything is encrypted between the server and the client. Client being browsers. So even going back to example given by Long, right? Curl allows both HTTP and HTTPS communication. Now, where does curl fall under? An application layer, right? Curl being an application layer, it uses some of the transfer and internet protocols to send and receive the data either securely or non-securely. If you're using HTTPS URL, say curl https .google.com / some file name, then it is going to use that encryption and decryption under the hood. Curl need not show you how it is decrypting or what protocol it's using. When you say HTTPS URL, you have already mentioned, that means it's an secure URL already. If it is an HTTP, it's an insecure. Sometimes curl will ask whenever you're asking, accessing insecure URL, it will ask to pass on the flag insecure or -k. I believe -k is something where you could say you can skip the HTTPS verification or SSL verification. Any questions here?
No.
Also, I know it's more than, I mean, it's almost nearing to 2 hours. Let me know if you want me to stop now. I'll probably take another 15 minutes and we can continue another session. But before 15 minutes, if you want to have a break or if you want to stop, let me know. It's for all.
I think we can continue, like, if it's another 15 minutes, we can continue and finish it.
Yeah. Cool. I see already audience is reduced to 7. So, one sec. Yeah, now we are going to concept network address. Obviously, I told you, right, an analogy of using post or the post office. You need to know the source address and target address to send the letter. Similarly, in network communication or the internet communication, you need to know the source and destination address. What address? That's where the complications come into. There are different types of address, which I'll discuss in this section. So address types, mainly, I mean, at the very high level, there is machine type. MAC address, what we say, is an machine access control address. And then there is IP, Internet Protocol address. Within IP, there are 2 versions, IPv4 and IPv6. Why there are 2 versions? Most of them you might know. We are running out of IPv4 public IP address. So there's, I mean, already IPv6 is developed and it's actively used in some of the, I mean, most of the applications now. Even Kubernetes, I believe, supports both IPv4 and IPv6 stacks. What does it mean? Nodes in Kubernetes can have both IPv4 and IPv6 addresses. We'll discuss what are those. And obviously, I am not much aware of IP version 6, like, what's the structure of it and how it works. I won't be able to discuss, but something, we can all go back and learn when it's required. Now, this is an example screenshot, this ties back to one of the CLI, which Long mentioned. If you type in ifconfig in Linux machine or ipconfig in Windows machine, you would see this machine. It basically lists all of the networking interfaces on your machine and what address they are connected to, and there are different fields. We can talk about all of them, but for now, let's focus on two. One, physical address. This is the MAC address I was referring to. Now, this one, as you can see, is provided by Hyper-V Virtual Ethernet. So it's very custom, and I can manipulate this. I can change this anytime. But if it is a physical interface, you can't modify this physical address. Some of the applications provide MAC address spoofing, which mask this and provide a different MAC address for different reasons. But again, network interface will have this address hard coded if it is not virtual, right? Similarly, then there is IP version 4 address. So this is assigned by Hyper-V, but in your physical interface, if you're connected to your local router in your home, your your ISP provided router will be providing this IPv4 address. How that is known, whether if you can see whether DHCP enabled is yes. Here it is no, but usually in your home network, DHCP will be enabled. There will be an option to we'll come to that later, but disable the DHCP and configure IP address manually. That is called as static IP address assignment. But by default, it will be dynamic, and by dynamic, it means your router is assigning IPv4 address to all of the network device which successfully connect to itself, the router. Yeah, now let's talk about MAC address. It's like, again, there are very logically level, it's divided into 6 octets, right? Each, what you see here is an hexadecimal representation, but those are internally converted to octets being 8 bits of binary. So each of these fields are converted to 8 bits of binary, and that's how it will define what is the MAC address and what are other properties. For example, this B1 flag, say very first octet, right? The very first octet where there is a provision for organizationally unique identifier, meaning there are 3 octets which are used by the manufacturer of the interface, who uses 8 bits from those 3 octets to define the address. Say, for example, 0015. Say this is an I manufactured this specific network device. This means this is uniquely owned by me. These 00 and 115, meaning say Broadcom is another network service provider. They will have their own unique identifier here. Some of network engineers, they can identify which manufacturer the network interface belongs to by just seeing the MAC address. That's the a level of usability they have just by identifying the MAC address. Now there is another flag called unicast and multicast. This defines whether this network will provide unified network casting, meaning it will connect to one device at a time, one another network device at a time, or it is can connect to multiple devices. This is again at the very physical level, because we are talking about the physical interface card or the network interface that will have this MAC address. Another name for this MAC address is burned in address, because it's burned into the chip, that flashed into the chip. That's what it's usually referred to as a factory provided address. Now coming to IP address, this is what we'll mostly use, been using. You will be seeing IP addresses. You will see all over Kubernetes development, ingress, egress, everything uses IP address. Your laptop uses IP address, your mobile uses IP address. You don't need to know what IP address is assigned to your machine to access any information, but that is required for communication to happen in the background. For example, say I can give a loose analogy, like you want to talk to your friend who is in a different city. You probably don't remember his phone number, on top of your head. It's stored in somewhere in your phone under the contacts. You just search for his name and dial in. You just don't need to worry about his number, right? If he changes his number, he will let you know, but assume it's not changed. You just search for his name, call. That's it. You don't need to worry about the IP address. So that's at the high level, a user level. But when it comes to Kubernetes development, ingress development, then you need to know what IP address is assigned to specific node to diagnose it if it is having an issue. And you need to know whether IP address are getting assigned to a pod. These are all very important, and you need to understand how these IP address are derived, how they are coming, why you see 10.100 in most of the Kubernetes clusters, not something like 84 or 44 to start with. Why not that, and only specifically 172 or 10 dot to start with? I'll come to that again. These are like unique in specified network, meaning in my home my laptop is assigned with 192.168.1.150. Say there can't be another laptop or another computer with the same IP address in my network. But in your home, you can have that same 192.168.1.150 because it's your own local area network. Those are private to each other local area network. But when it comes to internet, you can't have this 192 series, but there will be a different range of IP address, but they are also again unique. Meaning google.com will have some IP address assigned to it. Yahoo or Microsoft can't use the same IP address because it's not supposed to be happening. When Google is given specific IP address, only they will be the owner of it. Someone else will not be able to use that. That happens because that is required because it's unique destination, unique source are very much essential for the network communication. So now this IP address again, it consists of two components, network address and the host address. Why these will be important? To subdivide your network, meaning when it comes to organizations like a company or a bank where they have multiple computers in an office, multiple departments, they need to be divided logically, and they need to be divided at the network level as well. That's when this concept of subnet work comes in. A subnet plays very important role to logically separate the IP groups and identify that device. Meaning, say some information is coming from HR department to the marketing department. HR department will have its own IP address series, and marketing team will have its own. Now HR wants to send specifically to marketing, and they don't need to worry about specific IP in that machine as long as they know this range to identify whom they are sending to. By just looking at the first two or the network address bits, they will be able to identify which department it's belonging to. We'll come to that while we discuss more about subnetworking. Now let's look at how IP4 is formatted and how IP6 is formatted. Both are at the very base level are binary bits. It's all represented in zeros and ones. IP is using 32 digits of binaries, which are then converted to a dot decimal notation. But in IPv6, it's using hexadecimal bits. There are like, around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 separate 8 groups of hexadecimal digits. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 groups of hexadecimal digits, and each of them then converted to binary. Okay, so with IPv6 coming into use, will not be referring to some of the IP address like how we used to do, which was very easy earlier. Now it will be difficult, but we don't need to remember all the address, right? But just understand the structure of this, and this is all represented in hexadecimal. When it comes to IPv4, you need to know how they are classified, because even though IPv6 is coming into use, that's for the wider internet, publicly available address use case, meaning IPv address with 32-bit, we could only create, I don't know how to expand this, but this is the defined number of publicly available static IP address can be. We are running out of this. In fact, within a few years, we'll be running out, and most of the companies, they will continue to use existingly provided IPv4 address, but they can't provision anything new. That's one, all of the organizations related to internet communications like IEEE, ISO, and W3C, they all came into standardize a new version, that's IPv6, which uses hexadecimal. With this, there's like trillions or billions of address possible, which will probably no one will, humanity will never run out of an IPv6 address until the doomsday. Any questions here?
No, it was a nice explanation.
Means actually it takes binary. Then if we put a number, means by converting in human understandable number and put it, and can it uh, direct us to that website?
I mean, I'm not sure if I understand your question correctly. So,
Like,
say,
like this is 172.16.2541. We will convert it into 10-bit number,
yeah,
and if we put in browser, then can browser will redirect us to the website, or we have to put binary, or it will convert indirectly it to binary number?
yeah. So that is a different topic, like how the translation works. But very simple answer is no, because your browser is not designed to convert, uh, you know, uh, binary digits into an different IP address and then or directly reach to the target. No, it will only understand domain name like google.com or mail.google.com, or IP address of that domain. Will come to that point where we'll discuss how these domain names are associated with IP address. That's a different topic, but you can't put in binary address and then browser will automatically convert. But that doesn't mean it's not possible. You can write your own version of Chrome. That's Chrome is open source. You can write your own browser, and you can allow modify the code to use this type of an address. But why? Meaning, is that really required? I mean, by means of technically possible, yes, but for the use case, it's not so user friendly, right? I mean, first of all, end users find it hard to remember IP address, right? That's why we refer with domain names. Why we use google.com? Why don't we use Google's IP address? Because it's hard to remember those digits, dot decimal digits. Do you know address of any websites which would be in your head? Usually no. A common person or day-to-day user of internet, they wouldn't want to remember any numbers. All they want to type in some names which are easily recognizable. So you just type in that name and it translates to an IP address. That's a topic we'll come to later. IP address is translated in the background and then reach to the target. But at the end, over the processing level, machine level, that's where all the bits operation happens, right? It's not at application level. It's not at router level. It's at the router again at the chip level. It happens. I mean, that's the computer, right? Transmitters working, millions of billions of transmitters working on the chip, converting those zeros and ones constantly. You don't need to worry about that. That's why we are not using binary system. But if you are doing it in a fun way, why not? You can try to decode. It's redundant. You type in binary address, your browser converts that to an IP address or the name, but at the end, at the machine level, it goes back to binary again.
Yeah, got it.
Cool. So it's 3:30, guys. Let's stop here. I do have a lot of things to cover. We can have multiple sessions like this. Again, if you are actively participating, if you are interested.
Yeah, it was a nice session actually. I got a lot of help. Like, a lot of the terms that I got introduced.
Yeah, I mean, again, this is very beginning. You will come to some newer concepts which will widely use. Now it's an we are just trying to provide an basic understanding or the pillars for network communication, and then you have keys to the actual floors where you can explore few more things, which is interesting actually. This is all being theory, but I'll tell you next few sessions will be very interesting, and there can be participation from your side where you can actually do something on your machine and find out what's happening, and then we all will relate that back to those OSI 7 layers.
Yes, yeah, that would be awesome.
Yeah. When we go practically, it will be very interesting.
Yeah, definitely. We'll go to that. Meanwhile, if you have any questions, reach out to me in Slack. And if you are interested and if you have time, read about this. There's obviously all of this information. Obviously, it's not coming from my own input, right? This is all publicly available. All of this, I mean, these two diagrams. This representation of IPv4 and IPv6 is all coming from Wikipedia. I don't need to reinvent the wheel and type in all this. This is all readily available. But what I'm trying to put is put in a context, put in a presentable manner so that you can connect the dots later.
Yeah.
Cool. Thank you, guys. Thanks for showing interest.
Also, just one last thing. Could you share some resources for beginners?
Resources for
beginners?
Yeah. I mean, I'll share some links, but to start, you can search all the information readily available in YouTube, network fundamentals or basics of networking. It's all there are thousands of people who have put in very nice content in YouTube. But I'll share some of the interesting resources which I come across.
Okay.
Cool. I'm stopping the screen share and I'll stop the recording.